Good morning everyone. So in our last classes we have seen on the theorems related to systematic sampling. So in systematic sampling we have seen all the theorems, the different variances and the comparison of those variances with the other sampling techniques also. So we have seen the comparison between three sampling techniques, that is simple random sampling, stratified random sampling and the systematic sampling. Among these samplings, the stratified random sampling is more efficient than systematic sampling than the simple random sampling. Today we will be seeing a problem related to the systematic sampling. So coming to the question, a population consists of 15 units. So in the overall population, there are 15 units with 5 systematic samples. So in the notations also we have seen that we will be having the K systematic samples. Like that, here there are 5 systematic samples with each with 3 units, and each systematic sampling there are 3 units. So in first systematic sampling the units are 1, 4, 8. In the second sample the units are 6, 12 and 20. Next in the third sample 4, 8, 16. Next to sample 3, 10, 18. In the last systematic sampling, the units are 4, 12 and 24. So for this data, we have to, the combination of the question is, we have to calculate the variances. So here we have to calculate variances. So variances of simple random sampling, stratified random sampling, variances of simple random sampling, stratified and systematic samples. Systematic sample means, so from this, after calculating these values, we have to compare them. So this is the question related to systematic sampling, where 5 systematic samples are given. From each sample there are 3 units. So from this given data, we have to calculate the variances of the sample mean under the simple random sampling, stratified random sampling and the systematic sampling, and we have to compare those variances. So comparing the variance means we have to find the efficiency. So after finding all the 3 variances, we will check which variance is having which value is having the less variance, that is considered to be the more efficient. So coming to the solution, first we have to know the formulas, right? So first, variance of y bar n under simple random sampling without replacement. So we know this formula, that is n minus n by capital N into s square by n. So we have to calculate the s square value. We know the s square formula. 1 by n minus 1 double summation yij square minus n into y double dot bar square. So here capital N means we are using systematic sampling. So in place of capital N, we will be writing small n into k. Next, coming to the variance of the stratified random sampling. So variance of y bar st is given as, the variance formula is k minus 1 by nk, k minus 1 by nk. This we have used while finding the comparison in our previous class. That is, we will be using s square, but here s square will be using the value of SWST. We will be using the population mean square of SWST, that is when stratified is converted to systematic sampling. So what is the formula for S square WST? So S square WST is given as, the formula is 1 by n into k minus 1 summation I equals to 1 to k and j equals to 1 to n yij minus y dot j bar. So here we will be considering the mean of jth stratum, not the ith stratum. Here I indicates the systematic sampling. These are the strata, that is j. That's why we consider the jth stratum. So by simplifying minus 1 by nk into s square. Nk minus 1 by nk into s square. So here s square, that is population mean square, minus n minus 1 by n into s square w sy. So this s square w sy we have used in our theorem also. S square w sy is the population mean square of the units between the units within the same sample. So what is s square w sy formula is given as, we have used in this formula. So s square w sy is equals to 1 by k into n minus 1, 1 by k into n minus 1 double summation over I and j y I j minus y I dot bar whole square. So here we will consider the sample mean of the ith strand term, that is y I dot bar whole square. Now we count all the required formulas. So for this we need a calculation box, right? So now we will draw a calculation box for the given problem. So first is stratum, and here the sample, that is systematic sample. So we have total 5 systematic samples, write down 5. And we have 3 stratas, 1, 2 and 3. Write down all the given values, 1, 4, 8. Next are 6, 12, 20. The next values are 4, 8, 16 and 3, 10, 18. Next 4, 12, 24. Next columns we have to prepare is summation of yij. So summation of yij. So these are the yij values, and we are calculating row wise. That means for these stratas means j values. So that's why we take summation over j equals to 1 to n yij. Next we will be calculating yi dot bar. It is the systematic sampling. The systematic sample we will see. So these are the I values. So we will be taking yi dot bar. Next calculate yi dot bar square. So in our formulas we want yi dot bar square. So calculate yi dot bar square. Next is you calculate the last one as yij square. So here yij square, and you are calculating for the strata. So you will take summation over j equals to 1 to n yij squares. So these are all the values which I will be calculating for the rows. Now similarly for the columns also I have to calculate the values. So first here we have written yij. Similarly here also I have to calculate the yij value. So here I am calculating column wise. So column wise means I have to take the summation over I, because 1, 2, 3, 4, 5. These are the I values. So summation over yij, and next there we took yi dot bar. So here y dot j bar, because for the here we have considered yi dot j bar value. So square it y dot j bar square, and the last value is similarly we have written yij square, right? So last also here you will be calculating yij square column wise. So summation over, there you do summation over j, here summation over yij square. So these are all the values we are going to calculate for our given problem. So now we have to calculate the values. So we'll be calculating all the required values now. So first we'll calculate Yij, that is summation over j Yij. So add these values 1 plus 4 plus 8, you will be getting the value as 13, right? Yes. Similarly, 20 plus 12, 32 plus 6, you will be getting the value as 38. Next value is 16 plus 4, 20 plus 8, 28. Similarly, 18 plus 10, 28 plus 3, you will be getting the value as 31. 12 plus 4 is 16 plus 24 is 40. So this is Yij. Summation over j Yij. Now summation, you want the Yi dot bar. So the mean of the ith systematic sample. So we got summation Yij 13. So that 13 divided by how many values we have in the systematic sampling? 3 values. So 13 divided by 3, you will be getting the value as 4.33. Similarly, 38 divided by 3, we will be getting the value as 12.666. That can be written as 12.67. Similarly, 20 divided by 3, you will be getting the answer as 9.33. And 31 divided by 3, you got the answer as 10.33. And the last 40 divided by 3, you will be getting the answer as 13.33. So after getting this value, Yi dot bar square, that is 4.33 square, you will be getting as 8.75. I'm just rounding off it to 2 digits. 18.75. Next, 12.67 square, you will be getting as 160.53. Similarly, the next one, 9.33 square, you will be getting as 87.05. If you round off, you will get 87.11. 2 digits, 87.11. Next, 10.33 square, you will be getting as 106.78. 106.78. If you round off to 2 digits, you will get these values. Next, 13.33 square, you will be getting as 177.69. 177.69. So these are the values of Yi dot bar square. Next is Yij square. Summation of Yij squares. So that means these are the different Yij values. We have to square those and add those values. That is 1 square plus 4 square plus 8 square. You will be getting the value as 81. Next, the remaining value is 6 square plus 12 square plus 20 square. You will be getting the answer as 580. Next, similarly, 4 square plus 8 square plus 16 square is 336. Next, 3 square plus 10 square plus 18 square. The answer is 433. Similarly, 4 square plus 12 square plus 24 square is equals to 736. Next is similarly you have to find the values, the column wise also. First, summation of Yij. That means 1 plus 6 plus 4 plus 3 plus 4, you will be getting as 8. 18. Next value is 4 plus 12 plus 8 plus 10 plus 12. The answer is 46. Similarly, the last value 8 plus 20 plus 16 plus 18 plus 24, that is 86. Now we have to find the Y dot J bar, that is the mean of the wij squares column wise because the summation over I. Now 1 square plus 6 square plus 4 square plus 3 square plus 4 square. You will be getting the answer as 78. Next is 4 square plus 12 square plus 8 square plus 10 square plus 12 square. You get the value as 468. 468. And for the last stratum, 8 square plus 20 square plus 16 square plus 18 square plus 24 square is 1620. 1620, the value over there is 1620. Now what you do is find out the totals for the, if you find out total row wise and column wise, you will be getting here same value, that is summation of Yij is always same. Now find out all the totals. Now we will be getting the totals as the summation over Yij, that is row total or column total will be same. So that is given as double summation Yij equals to 150, and summation over I dot bar is 49.99, and summation over I dot bar square is 550.95, and the last summation over Yij square is 2166. This value and this value row wise and column wise will be same because it is dependent on the Yij's values. Yij's total or their squares will be same. Similarly, summation over y dot j bar is 30. Summation over y dot j bar square is 393.44, and double summation over I and j Yij square is the same 2166. I took after point 2 digits. If you take after point 4 digits, you may be getting a slight variation, not much. Only after the point, the second or third digit will be changing. So don't think that your answer is wrong. It will be almost carefully. Next, what are the values we got? Now we will be substituting in this 3 formulas. Now we will substitute the values in the 3 formulas. So now I will calculate the variances. First I will be calculating the variance of y bar n under simple random sampling without replacement. So what is the formula? N minus n by capital N into s square by n. So for this, first I have to calculate the s square value. So where s square equals to, we will be writing 1 by capital N minus 1, right? So here what is capital N means? N into k minus 1 double summation over I, and summation over j equals to 1 to n. You will be getting Yij square minus, what is the s square formula? Capital N into y bar square. So here capital N means n into k into the mean value, that is y double dot bar square. So we have to calculate the y double dot bar also, that is the population mean. So what is the formula for y double dot bar? Y double dot bar equals to, you can use either y dot bar or y dot j bar. I am using y dot bar, so 1 by k summation over y dot bar. So 1 by k means how many systematic samples we have? 5 systematic samples. So 1 by k into summation of y dot bar. The summation value is 49.99. So 49.99. So 1 by k means 1 by 5. So therefore y dot bar value is 49.99 divided by 5. We will be getting approximately 10. So I am rounding off the value and taking it as 10. So instead of this, you can use the other formula, that is small n, that is 3. Now calculate this value. You will be getting variance of y bar n under SRS WOR as calculate the value. You will get the random sample variance as 12.69. So this is the calculation of variance for the random sample if the systematic data is given. Now we will calculate the variance of the next sampling technique, that is stratified random sampling. So I need the data, so I am giving the table as it is. Now variance of stratified random sample mean, that is stratified sample mean. So stratified sample mean means variance of y bar st. So variance of y bar st equals to, we have to find it here again, s for one more s1, that is for st. The formula is k minus 1 by nk into s square of wst. Yes, s square of wst, where s square wst formula is given as, so we have the formula as 1 by n into k minus 1 into double summation over I times j by ij square minus k into, here I am considering k, so k into y dot j bar square, because SWST, it is related to the jth sampling units, not the ith stratas. Sorry, jth stratas only, not the ith sampling units. Always j indicates the stratas, right? 1, 2, 3 j values are stratum values. So here we are calculating for stratified random sampling s square wst. So we take y dot j bar square only. Now substitute all the values. S square wst is equals to, you will be getting as 1 by n value is 3 into k value is 5 minus 1. So double summation by ij square value. What is the double summation by ij square value? We got 2166. So 2166 minus k into 5 into y dot j bar square value. We got it as, so this is y dot j bar square value. We got it as 393.44. So substitute that value 393.44. Now find out the, solve this one and find out the s square wst value as, we will be getting s square wst value as 16.57. So substitute the 16.57 in the variance of y bar st formula. So variance of y bar st equals to k minus 1, 5 minus 1 into 3 into 5 into s square wst value, we got it as 16.57. So therefore, variance of y bar st, that is for stratified sample mean, will be getting as 4.42. So remember the previous random sample variance. This is the stratified sample mean variance. Next we will find the systematic sample variance. Now we will calculate variance for systematic sample mean. Variance of systematic sample mean. So coming to variance of systematic sample mean, what is the formula? Variance of y bar sys equals to nk minus 1 by nk SY, that is the population mean square between the units of the same systematic sampling. So what is the formula for S square WSY? So S square WSY is equals to 1 by K into N minus 1. We have used this one in our theorem. 1 by K into N minus 1 double summation over Ij by Ij minus, here we are using the ith systematic sampling, so by I dot R whole square. Now if you simplify this one, you will be getting the S square value, that is S square W Sy equals to 1 by K into K into N minus 1 double summation over I and j by Ij square minus, if we have used S square SWT, what we got? We have used K into, right? So here we will be using N into by I dot bar square. So remember, that is for the strata and this is for the systematic sample. So here we will use N into y I dot bar. There we will be using K into y dot j. So substitute the values. 1 by K value is 5 into 3 minus 1 into double summation y square is 2166 minus N into, that is 3 into y I dot bar square is 550.95 square. So solve this one, you will get S square W Sy value as so S square W Sy value will be getting as 51.315. Substitute this value in variance of y bar Sys equals to Nk minus 1, that is 5 into 3 15 minus 1 by 15 into S square. So S square value we have already got for the random sample, right? There we got the S square value as 47.57. So 47.57 minus N minus 1, that is 3 minus 1 by 3 into S square W Sy value, we got it as 51.315. Now solve this, we get the variance of the systematic sample mean equals to, here we getting the answer as 10.19. So we have got all the three variances. Now comparison of these variances means write all the variances and check which sample mean is having the less variance. So now comparison of the variances. The random sample variance we got it as 12.69 and the stratified sample variance we got it as 4.42 and the systematic sample variance we got it as 10.1. So from all these three it is clear that 4.42 is less than 10.19, which is less than 12.69. So that indicates that variance of stratified random sampling is less than variance of the systematic sampling, which is less than the variance of the random sampling. So here if we observe, theoretically we have proved in the last class theorem, if you observe in practical problem also, the variance of y bar st is having the minimum variance. So that means the variance of y bar st is minimum. Therefore, stratified random sampling is more efficient. Stratified random sampling is more efficient. So whenever they ask the efficiencies, you have to calculate the variances and have to compare those variances. So this is the formula related to the stratified systematic sampling. So from systematic sample data, we have calculated the random sample mean and the stratified